Hi, I'm Lee Goldberg, and welcome to Electronic Design's Tech Exchange series. In this episode, I'll be talking with Jane Neelix, CFO of SES Corporation, a manufacturer of high-performance lithium metal batteries. First one is conventional lithium-ion batteries are experiencing steady gains in cost, the ones we've got on the market today, and performance, but will they be enough to give the EVs a market advantage over internal combustion powered products in the near future?
Yeah, so in recent years, the conventional lithium-ion batteries has experiencing a lot of growth as we've seen the market from cost, capacity, and performances. And the Biden administration announced the goal of getting to 50% electric vehicle sales by 2030. Although the EV penetration in the US is still relatively low comparing to some other countries, but we are seeing rapid growth in the market. Right? In the recent quarters, the overall EV penetration of new car sales in the US has been somewhere around 8%. And then European countries, the penetration is much higher.
Yeah.
And we see most of the car companies in the world has announced to be all EV between 2030 and 40. But to answer your question, I think the conventional lithium-ion batteries are not enough to give EVs the market advantage over ICE to get us to the penetration that we wanted to see in the future. We need a significant step up in technology to solve some of these current range and fast charging anxieties customers like myself have.
Right.
That's what we're trying to do at SES to commercialize the lithium metal battery technologies to solve some of these issues.
Would you care to talk a little bit then about what specifically is kind of putting a ceiling or slowing down improvements in conventional lithium-ion battery technologies, and how now you folks manufacture lithium metal battery architectures? How do they overcome them?
So most of the improvements in the traditional conventional lithium-ion batteries has been on the cathode side. We hear LFP cathode for economic cars, and then NMC high nickel cathode for premium cars. Recently, we've heard LMFP and other type of cathode technologies that's improving lithium-ion battery performance. But I don't think there's one solution, right? So the cathode improvements get to a ceiling. Now, the next generation new battery technology will be on the anode side. That's what will break the limits of lithium-ion and provide a revolutionary step change in the battery performance. And that's what lithium metal basically is doing.
Yeah. I just did a big feature on batteries, and I did notice that lithium metal or lithium anode batteries do show a lot of promise, and they still do tend to, the ones I was looking at anyway, I couldn't cover them all, have a number of issues with mechanical expansion and other issues that limit their life and make them very difficult to manufacture. How does SES overcome those problems?
First of all, maybe just back up one step. Lithium metal technology, battery technology, is to replace the graphite anode in the current lithium-ion battery with lithium metal. Right, and that's what provides the high energy density, fast charging, and all the capabilities and step change in battery technology. But lithium metal has its own issues to solve, and lithium metal itself is not new, right? It has been around for more than a decade. One of the major technical issues to solve to commercialize lithium metal is the dendrite issue. To solve this problem, different companies are working on different approaches. Solid state is one approach. but it's very difficult to manufacture, and there's no really line of sight to scale for EV applications. Now, at SES, our approach is a little bit different. It's really in our innovative proprietary the electrolyte composition. So our approach is liquid, but it's a very different type of liquid electrolyte. Our electrolyte uses high concentration solvent-in-salt approach, which is different from the conventional liquid electrolyte that's in today's lithium-ion batteries. So basically, if you think of a cup, right? Today's lithium-ion battery has electrolyte, and it's more like a cup of solvent with some salt in it. It's very liquid, and it's more flammable, and it caused the dendrite issue, which I will talk about a little bit. Our electrolyte is high concentration solvent-in-salt, so it's the other way around. It's a cup of salt, and with just a couple drops of solvent, and then the solvent will coordinate together with the salt, and is not flammable. It's much safer, and it changed. But the main breakthrough is it changes the way dendrite grows. If I look at I have another slide we can show. On the left-hand side, that's the dendrite.
Okay.
So basically, dendrite is referring to the needle tree-looking structure, which will grow for lithium metal technology, right? That has been an issue that the scientists have been working on for many, many years. And then it will break through the separator and then cause shorting and safety issues. And our electrolyte, the high concentration solvent-in-salt electrolyte, basically changed the way dendrite grows. It's no longer dendrites. It's mossy lithium, which is the picture you see on the right. That's a hilly structure which doesn't poke through, right? So this is really important technology that's really core to us. It changes the way dendrite grows and become mossy lithium that solve the major technical issue to kind of break through lithium metal and get to commercialization.
This is a really dumb question. I mean, I've been covering batteries now for a couple of years and I'm fascinated, but my knowledge is still so limited. If you have so little solvent, how do you get mobility and a uniformative reaction through the entire structure of the cell without as much liquid medium?
So the high concentration solvent-in-salt electrode technology, the solvent is coordinated by the salt. So, but there is no free solvent molecules. But the ions still go back and forth between the anode and cathode.
Okay.
So it's not like it's going like liquid water going through, right? But the ions still go through. That's what the discharge and charge happen.
This would mean you have a much higher power density, I think, per kilogram and per unit volume.
The main advantage or the reason why OEMs are working with us and helping us to commercialize this technology is because it provides a step change on the energy density, both on the watt per kg and watt per liter basis. So our projected the energy density is 400 watt per kg and 1,000 watt per liter. Energy density that would lead to a significant longer driving range, in addition to many other advantages that lithium metal battery provides.
So what does it mean? So you've got a denser, so we're talking about back to performance. You have a denser battery with a higher kilowatt hours per kilogram, and and
Yeah.
also per unit density. What does it represent percentage-wise over today's? I'm trying to cast back in my mind to remember what a uh, typical battery pack from say Tesla or Hyundai gets these days, and I'm drawing a blank.
Our lithium metal batteries are denser, right, with projected 400 watt per kg and 1000 watt per liter energy density, which would lead to a significant longer driving range for the end consumers.
Right.
And it is lighter, it's much lighter. Our ultra thin lithium metal anode reduced the battery weight significantly, by like almost 50%. That's another big advantage the OEMs love, right? They want to have lighter batteries. Today, our cars with the lithium-ion batteries, on the bottom of the car, is very heavy. With a lighter battery, a lot of other design changes and materials can happen to reduce the overall cost of the car. So lithium metal is much lighter and is faster. We are already right now capable of charging 80% within 15 minutes, right? Charging anxiety is another issue that future batteries need to solve. It is smarter. I'll talk a little bit more about our AI-powered algorithm to optimize and performance. So it is smarter, and is safe with our electrolyte and the AI as well. And in addition, this is not really about performance, but lithium metal has been around, but at the end of the day, it has to be practical and scalable for us to commercialize. And our approach to lithium metal is very practical and scalable. That's another reason why OEMs would work with us to try to commercialize the technology.
You touched on one big, by the way, you touched on several big things. First, people were having range anxiety. Then now the big thing is charge time, and apparently you've been able to attack that. The lithium metal architecture charges faster. And of course, the other big issue is cost. What kind of cost do you expect at the? We can't talk about the retail, but at the wholesale level, to manufacturers, cost per kilowatt hour. Do you care to project, any kind of price range or percentage of reduction over the current ones?
Because we're a public company, so we can't really put out a number, but what I could say is, first of all, our technology is on the anode side. So any improvements on the cathode side, we can take advantage of. Our battery could use LFP cathode or high nickel cathode. So it's not limiting to one type of cathode. And then the future battery technology, the cost will continue to come down as the industry evolves and more capacity is picking up and different type of cathode and lower cost. So we anticipate that our cost will be in line with lithium-ion cost at that time, whenever that time is in the future, and is maybe even lower when we are at scale,
at high volume.
Yes, yeah, because there will be a ramp up. We're not gonna be at low cost on day one, given the lithium ions are in the multi gigawatt hour already. But it will get there.
The next thing on my list here is what role does your artificial intelligence technology play in optimizing your battery's performance? Is that in the design or the actual battery management or the manufacturer? And does it add anything to the cost of a typical battery pack?
Yeah, that's a great question. Is everywhere actually. I love talk about the AI piece of it. It's very exciting and it's unique as well. So we have been doing the AI piece since more than 5 years ago. So this is not something we just started doing. We started doing that really out of necessity, because if you think about EV, the total industry, right? Right now, all the battery companies predict failure of the battery by part per million. Basically, out of 1 million cells, one might fail, whatever that rate is a ratio. But they don't know which cell in which module, which pack, which car failed. That's why OEMs has to recall all the cars
Right.
produced in a certain time period that particular cells might have failed. But in the future, when the penetration is 50, 60, 70% or all EV, you can't do that, right? Part per billion is still a lot of failure.
The Bolt
Yeah.
nearly killed GM, and it was a relatively low volume mistake. Right.
Yes, right. So more than 5 years ago, we thought we need to have the AI in the battery at the cell level to, one, predict safety, and two, know exactly what happened or will happen at the cell level, not at the pack module car level, like at the cell level, right? So what our AI been doing, and we're still training the module, is a process. Is we gather the data from, so there are three sets of data that we gather. One is the material data, so what goes into the battery, right? Two is the manufacturing data, how the battery is manufactured. And third is the usage data, how the driver, the consumer use the battery in different conditions. Those three factors impact how the battery performs and how long the battery will live, right?
Right.
Like a person, and it's the DNA and how we grow up, the environment, and all that stuff play a role. So battery is the same. So we gather these three sets of data, and then we have the AI algorithm to monitor and predict issues with the battery. And then that AI platform eventually would be in the overall BMS system of the car. So in the future, the goal really, and then this is something the OEMs want, is to be able to say cell number 1, 2, 3, 4 in this pack, this car. That's
so
having issues.
So you're monitoring the behavior of individual elements within the big battery, within the main battery pack. So if the AE35 module goes, you can smell it before it becomes a problem.
Yes, so predict the safety ahead of time, so the consumer could get warning, alert, whatever, or the battery can go through self-healing process, whatever it needs to be done. And then two, the recycling value of a battery is different depending on how we drive it, right? I live in California, which is warm and sunny and nice weather.
Will it add much to the cost of a battery pack?
No, not really. I mean, it wouldn't add the cost to the pack itself. I think it would add value to the pack or BMS system. Whether there's opportunity to charge for it, we'll see. But no, it wouldn't add cost to the pack, and also just kind of give a sense of scale, right? If you think about, we work with GM and Hyundai and Honda. For example, GM's Hummer EV that hopefully will come out looks really cool. It has probably more than 300 cells on the bottom of the car in one car. That's a lot of cells. So we want to be able to predict and know what's going on in each cell in the car. when there are millions of cars on the road.
Can a vehicle equipped with SES technology be charged at a conventional charging facility?
Absolutely. It doesn't matter. Whatever charging infrastructure is being built or will be built, doesn't matter for our battery. Yeah.
Okay. So not only are you cathode agnostic, you're also charger agnostic, and you can fit into the entire EV ecosystem. One of your announcements mentioned the fact that both BMW and Mercedes have announced new classes of vehicles that are not SUV sized, and will when they're come to market, probably around 25, 26, they'll offer ranges that approach 500 miles. Now, given what you've been talking about with the improvements in the density and weight of your technology that it enables, is this related to any of your company's announcements, and what does this mean for Tesla?
First of all, it's not related to our technology. Secondly, I think one of the things that I think consumers don't really know or need to know is battery performance is an envelope of things, is never one particular thing. When you say 500 miles, there are a lot of things play into it. Is it 500 miles in Boston versus California? Is it 500 miles, however you charge it? How many cycles the battery will last, right? Each OEM have their own warranty, but usually they want the battery to last 250,000 miles lifetime, or maybe, somewhere between 200,000 to 250,000 lifetime. So that is cycle life, how many cycles times how many miles each cycle can drive. So however you get there, if it's 500 miles times 500 cycles versus 300 miles and you times a different cycle life. So it's a spider web of things where it lands. It never is never the same miles in different conditions.
As batteries improve in terms of density and weight, that we can move away from the SUV sized vehicles that we require today to carry around enough batteries to get them from point A to point B, across reasonable distances. I guess that's what you're saying.
Yes, so we will get there. Our technology, that's one of the so we will be able to get to about 500 miles per charge in different conditions. That's the goal. You need to get there in order to, in my mind, for EV to penetrate significantly in the market. Today we have basically the lithium-ion battery using two major types of cathode, right? The LFP cathode, which is cheaper, much cheaper, but it's lower density, less driving range. And then there is the high nickel cathode, which most of the premium vehicles are using, that provides higher density, better driving range. I'm sure the Mercedes of the world are using the high nickel for sure. And then our technology is on the anode side. So if we pair the lithium metal anode with the high nickel, with the LFP cathode, it gets to similar performance as today's high nickel cathode, which is a lot more expensive because there's nickel in it. And then if we pair our anode with the high nickel cathode, it's a whole new premium car that we don't even have today, right? So that's the whatever plus the whole new level of premium that has much longer driving range and all the other benefits. So that's sort of where the future is, as far as battery performance for EV applications. There is one more thing I do want to mention. is the UAM market, is urban air mobility.
I,
Um,
as a pilot, it's one of my favorite subjects.
oh, okay, yeah. So maybe you can have a whole different section on this one. We announced not long ago that we're getting into the UAM market. We're working with one of our partners to setting up a manufacturing pilot line to make UAM cells. The reason being the vision we have is similar to what lithium-ion did back in the 90s when they first came out. Panasonic had it. It was to commercialize the or enable the electronics market.
Yeah.
The Walkmans that we had back in the day.
Oh yeah.
I am old enough to have had one of those. But lithium metal will be the technology to enable UAM in the future.
Yes.
As a whole new market.
I
when we get there, right? Because it's light, it's lighter.
So Jing, thank you so much for your time and for using small words so I can understand them. I really appreciate it.
This is fun. This is fun. Thank you for having me.